So one more time. We jumped into Module 3 in March because somebody higher up than me said, hey, you're going to jump into this Engage New York after you've been teaching your way the entire year. Forget about that. We're just going to do this. So that's where we're at. Unfortunately, Module 3 required Module 2 and Module 1, which we didn't do. So before we go to the next lesson, you need to know how to solve equations, which was done in Module 2, which again, we didn't do. So I'm going to give you some pre-teaching here. We have done these types of equations. You've done one-step equations. I even gave you a quiz and then a day to fix that quiz. That was our last big grade in this class. So, refresh my memory. What is our first step anytime that we have an equation? Tegan?
Find the balance point.
Find the balance point. The balance point is always my equal sign. That's where we're going to try to keep everything level. Now we're looking at inverse operations. I want to read my problem first. -3 plus x equals -7. What's the goal of an equation, Brooke? To isolate the variable. That means get x by itself. So that means we need to move this -3 away. What is the opposite of this -3, Addie? I almost called you Abby. Yeah, adding 3. We're using our inverse operations. -3 plus 3 is 0. X is now by itself or isolated. -7 plus 3 is -4. Now, one of the things that I used when I was teaching 6th grade and I haven't been using, and I don't know why, is this idea of closing our eyes to think about a number line. So bear with me. If you're having trouble doing negatives and positives, just bear with me, okay? I'd like everybody to close their eyes right now. So close your eyes and in your mind start drawing a line. So you should see a nice big line, okay? Somewhere on that line, put a point that says 0. Okay? Keep seeing now, keep counting up on that line. So put a part that says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Slide your eyes back to 0 on that imaginary line. What are we going to have to the left of that 0?
Negatives.
Negatives. Let's go -1, -2, -3, -4, and so on and so forth. Okay, is everybody able to see this number line in their head?
Yes.
Okay. I want you to think that you've got a little bunny, a little person, somebody chilling at -4. Okay? You have that thing at -4? It can be a ball. I don't really care what it is. It's saying in this problem, -7, we're adding 3 to it. Which direction is our ball, bunny, person going to have to move? Right or left?
Right.
Right. So bump it up 3 places. Okay, was everybody able to see that in their mind of how we're going to go, okay, there's -7, up, up, up. Now I'm at -4. Okay, open your eyes. When I taught 6th grade, truly, I would have kids taking tests, and all of a sudden you'd see them close their eyes, and I'm like, wow. Like, it kind of looked like they had a twitch, but this was a great thing that they did that I enjoyed using because most people are visual learners. If you can see it in your mind, you're able to at least do the positives and negatives a little bit better. So that's just another tool to try to use. I know it's late in the year, and I forgot to use it earlier, but it's something that I liked using. So that's how I get x equals -4. Questions there? Okay. First step, always, Noah.
Find the balance point.
Find the balance point. Have you found your gum yet? So now we've got 3 plus x equals -7. 3 plus x. Again, the goal is to do what, Anna? What's the goal of any equation? Isolate the variable. Okay? 3 plus x. Weston, how do I move a +3 to the other side? What's the inverse?
-3.
Yeah, subtract 3. So that's 0. X comes down. Again, this is another one that I can close my eyes. Okay, I'm here at -7. I'm taking away 3 more. That puts me down at -10. So if you're having trouble with those positives and negatives, use that imaginary number line. I need nose trumpets if you got the first 2 correct. Okay. Can somebody read number 3 for me? I want it mathematically sound. I need you to read number 3 for me. Braden?
7 equals x over 3.
It's not quite mathematical. Corey?
7 equals x divided by 2.
Okay, so we want that division. Because when I read it like that, Braden, now I know what operation that is. Does that make sense? So now I have x divided by 3. What is the inverse, Liam, of division? Multiplication. What am I going to multiply both sides by? What's the goal? What's the goal of the equation? So we're trying to get x by itself. What's on the same side as that x? So we're going to multiply by 3. So that leaves me with x equals, now I have to multiply 3 multiplied by 7 is 21. As Mrs. Armstrong called it earlier today, moose ears if you got that one correct. Can't believe you guys do this stuff.
You did it.
So awesome. Emma, did you miss that? Then what should you do, Emma? Come on, let me see your moose ears. Moose ears. No? You're no fun. Nevaeh, you have a question? Or you just...
Oh, I don't know why my hand was up.
I don't either. You were just holding your hand up?
Oh, his hand. Yep.
Okay. Just keep it up there. Just resting, just drying out my armpit. It's good. Okay. Here we go. Nevaeh, since your hand was up, what's my first step?
Oh, find the balance point.
Find the balance point. Kylie, do you think you can read this one mathematically?
12 equals negative 3x.
Okay, so that's negative 3x. What operation is negative 3x? So I could say it's 12 equals negative 3 multiplied by x, right? Okay, both ways are sound. So, Cole, if it's multiplication, what is the inverse? What are we going to divide by, brother? By what?
3.
By what?
3.
By what?
3.
Oh. By negative 3. Hey, Cole,
Yeah.
what would be a negative divided by a positive? Negative. Do we want a negative variable? No, we want a positive variable. So negative divided by negative is what leaves me with a positive 1x. That's why I'm dividing by that negative 3. Does that make sense? But we have to do that to both sides. 12 divided by negative 3 is negative 4. Is this how I want it written? Macy, how would I change this to write it correctly?
X equals negative 4.
Yeah. Is this wrong? No. But I like to have my x's first. Okay? Last but not least, who can read me number 5 correctly? Go ahead, Brooke.
Negative x divided by 2 equals 6.
Good. So we know it's a division problem. We know that we're going to find the balance point. Avery, what is the inverse of division? Multiplication. Now, Avery, please be careful. What am I going to multiply by in this problem? By what? So, Avery, I'm going to read this question to you again. 2 multiplied by negative x divided by 2. If I multiply a positive by a negative, does that give me a positive? Okay, because the whole fraction is negative, we want to multiply by a negative. Because really this is a division problem, and that gives me negative 2 divided by negative 2, which is positive 1x. 6 multiplied by negative 2 is negative 12. Hand up if you got all 5 correct.
I got 4.
Okay, so it wasn't all 5.
Yeah.
Okay, let's try again. Braden, how many did you get?
4.
Nice! Put your hand up then. Okay, just make sure. Questions there? Okay, so I would have that warm-up paper out because you're going to be doing a lot more practice problems, but you're not going to write on the note paper. So I'm going to put some notes up here that you need to have on a separate piece of paper because you will be able to use these on your quiz and on your test if there is nothing else written on them. Does everybody understand that? There is not going to be anything else written on them. So on this piece of paper, on a different piece of paper, you are going to write down these notes. Sorry. So there is your anchor chart. There are your notes. We are going to leave it up there but you need to have these copied down on a separate piece of paper. Copy them down and then leave these steps on your table. Go. If you're having trouble seeing it, it says Module 3, 7th grade, equations. Number 1 is find the balance point. Well, we did that. Step 2 is if needed, distribute. Doesn't necessarily mean we're going to have to. Step 3 says if needed, combine like terms on the same side. Step 4 is combine the constants. Well, we know constants, they're the numbers that don't have variables, on opposite sides using inverse operations. And step 5 is isolate the variable by using inverse operations. Show me that you're done copying these down by setting your pencil down, please. So once you're done, just set your pencil down. So make these very neat because this is what you're going to be able to use on your quiz and on your test. Okay, these are going to stay up here, since most of us are on step 5 at this point. Truly, do not write on this paper. So you should have your warm-up paper out or something else so that you're able to do these examples. Because I'm going to show you one, and then it's going to be on you and your group. Because following these rules, no pressure, my first hour crushed it. And I think you guys are, okay? You usually do better at these kind of things. So prove to me that I'm not wrong. So here's example 1. I've got 3x plus 10 equals 22. So you are not writing examples on your rules. Have your rules out so that you're able to look at the rules and start to understand how to follow them, because that's going to be a huge thing. Okay, always, Mr. Irvin, where do we start? Find the balance point. Balance point is always at the equal sign. So now here's my question. How do I know when I need to distribute? What's a good key or good thing to look for to know when I'm going to have to distribute? What are we going to look for, Corey?
If there's something smack dab up against the variable.
Not smack dab up against the variable, smack dab up against, Brooke? Parentheses. So we look for parentheses. If there's something smack dab up against parentheses, that's when we're going to multiply, okay, and distribute. Are there parentheses? So do we need to do distribute, which is step 2? Okay. Step 3, if needed, combine like terms on the same side. So now we're talking about sides. We've drawn this dashed line, the balance point. There's a side. Are there like terms on that side that I can combine? Is there anything over there with 22? No. How about on this side? There's 3x and 10. Can I combine 3x's and 10? No. So is there anything to combine on the same side? No. So now we're at step 4. It says combine the constants on opposite sides using inverse operations. What are the constants in this problem? And we can come over here and we can look at this expression, and we know a coefficient is the number in front of a variable. The constant doesn't have any variables. So again, in this equation, what are my constants? Brendan?
10 and 22.
Positive 10 and 22. What's the goal of any equation? What's the goal of any equation, Tegan? Isolate the variable. So, Brendan, do I want to move the 10 to the 22, or do I want to move the 22 to the 10? If we're trying to isolate, which means get this by itself.
10 to the 22.
Good. What's the inverse of positive 10?
Negative 10.
Yeah, subtract 10. So we're going to subtract 10 from both sides. That's 0. 3x comes down, equals 12. Everybody with me still? We need to write this down, Izzy. So now I have 3 times x equals 12. Our last step, 95% of the time, will be to multiply or divide to isolate the variable. Not every time, but 95% of the time it will be to isolate the variable with multiplication or division. So we're going to isolate the variable by using inverse. This is 3 multiplied by x equals 12. So Macy, what's the inverse of multiplication?
Division.
So what am I going to do?
You're going to divide.
By? If the goal is to isolate the x, which means get the x by itself.
3.
By 3. Good job, honey. 3 divided by 3 is 1. 1 what? 1x. 12 divided by 3 is 4. Questions on how I followed those steps? Okay. So you're using those steps, you're using each other. 15 equals 5 minus 2x. Solve. Use those steps. I want to hear you talking it over with each other. Try it. See what you need to do by following the steps. You should be reading the directions to yourself and then see what you need to do to get the answer. Once you have that answer, talk it over with the people around you. seen a lot of good work, seen a lot of good answers. I would say for the majority, we've done pretty well. Okay, I need somebody who feels brave to walk me through not only the problem, but the steps. I've heard a lot from Brooke. I need somebody else. Go ahead, Ms. Bush.
So the inverse operation of positive.
Can we follow the rules a little bit?
Okay.
Okay.
So you gotta find the balance point.
Which is going to be where?
The equal sign.
Okay. Step 2 says if needed, distribute. How do I know I don't need to distribute?
There's no parentheses.
Okay, no parentheses means no distributing. Good. Go ahead.
Combine like terms on the same sides. There's no like terms on the same side.
Because why?
Because it's not 5x.
Yeah, it's not a 5x. What about on this side?
There's only one.
Okay, go ahead.
And then combine the
Yep.
Yeah, combine the constants on the opposite sides.
Okay, so if you can't hear in the back, Brandon said combine the constants on opposite sides. What are my constants?
15 or positive 15 and positive 5.
Okay, positive 15 and positive 5 are my constants because they don't have variables. How am I going to combine those?
You're going to subtract 5.
Good, because I'm trying to isolate my x. I'm moving things away from that x. 5 minus 5 is 0. Go ahead and tell me what I need to write.
It's going to be positive 10 equals negative 2x.
Okay, so if I had one problem with your guys' work, is I didn't see a lot of these negative 2x's coming down. Okay? The negative has to come down with it. Now what do I do?
Since it's multiplication, you're going to divide it by negative 2.
Divide by a negative 2. Good. Negative divided by a negative is positive. Leaves me with x equals.
Negative 5.
Okay. Is this wrong? Absolutely not. Is that the way I want it written? So what should I say?
X equals negative 5.
X equals negative 5. Questions, concerns, problems on how I got that one? Let me see my nose trumpets if we got that one right. I feel pretty good with this. You guys did very well for your first try. Here we go. Let's try another one. Let's go. 3x plus 4x equals 21. 3x plus 4x equals 21. So again, once you get it on your own, talk it over with the people, use the rules, see what you come up with. Oh man, I'm seeing even more right answers on this one. Awesome. Perfect. Okay, Emma, you ready?
4.
Sure. That was not confident, but okay. Emma, first step, go.
Find the balance point.
Okay, where's that going to be? Good.
And you don't need to distribute because there's no parentheses.
No distributing, I love it.
So you can combine like 3x and positive 4x.
Okay, so on this side, 3x plus 4x can be combined because they're both having the same variable of x, and the coefficients I can combine, right? So what's that give me?
7x.
So now I have 7x equals 21. Okay. Step 4. Are we combining constants? No, because there's no constants. We have a coefficient and a variable and a constant, okay? So step 5 says isolate the variable.
Divide both sides by 7.
Divide by 7. 7 divided by 7 is 1x. 21 divided by 7 is 3. And I would say I saw about 75 or 80% of you who got that one. Hand on the heart if you got that one right. Maybe even more than that. Okay, so if you're missing these or you don't have 3 problems written down on your paper, you should really do that. You should fix your answers because this is part of your practice right now. Okay? Questions on 1, 2, or 3? Okay. Here we go. 3x plus 7 minus 5x equals negative 5. So this is number 4. 3x plus 7 minus 5x equals negative 5. So you've been doing good work on your own, but I do want to hear you talking it over with your group. You usually do great with this. So again, once you have your answer, I want to hear you trying to rally coach your peers. So we should be working on this number 4. Okay, so I see a lot of your pencils down. This is where I want to hear you start talking to your peers. Use those mathematical terminology words that we came up with at the very beginning of class.
You showed me that. I saw that. I was criticizing. Oh, that's close.
You could have just erased that.
Oh, alright.
Okay, Weston. You ready? Okay. Talk me through it.
First you gotta find the balance point, which is the equal sign.
Good?
And then you don't need to distribute because there's no parentheses.
So far, so good?
And then you gotta combine like terms,
What are my like terms?
3x and negative 5x,
Oh, perfect. 3x and a negative 5x. What does that give me?
negative 2x.
Perfect.
And then you also have, oh wait, no.
Hmm?
You don't need to do anything. Wait, no, there's positive 7.
Positive 7 has to come down, good.
Yeah.
And that's going to equal negative 5, right? Okay. Now what? What's the next step?
Combine the constants.
Okay, what are my constants?
Positive 7 and negative 5.
Okay, how do I combine those?
You use inverse operations.
So what am I going to do?
The inverse for positive 7 is negative 7.
Good.
Do that one.
Okay. So that gives me negative 2x equals, what kind of 12? Negative 12, good. Am I done?
I messed up.
Well, so far you're still doing good. You have negative 2x equals negative 12. So what is negative? So we're at that last step. Isolate the variable by using inverse.
Isolate the variable, so you do is multiplication, so you do the inverse, which is division.
Good.
Negative 2 divided by negative 2.
Good. So negative 2 divided by negative 2 is positive 1. X. Negative 12 divided by negative 2? 6. Thumbs up if you got that one. Okay, that one was a little bit tougher. Questions on how I got that? Okay, we're going to do one very similar to that. You no longer get the opportunity to back out of an answer. I just get to call on you. 2x plus 7 plus 4x. So we have 10 equals 2x plus 7 plus 4x minus 3. This one takes a little bit more work. Again, talk it over, please. Okay. Izzy, let's go. First step.
We have to find the balance point.
Find the balance point, which is the equal sign. Okay. Step 2.
We have to
What's step 2?
we have
Okay, how do I know if I need to or not need to distribute? That's not distributing. How do we know whether we need to distribute or not distribute? Distribute means multiply. Tegan, can you help her? Yeah, if there's something smack dab up against the parentheses. Okay, keep on going. So there's no need to distribute, there's no parentheses. Okay, on the same side. So what do we have on the same side? 2x and a positive 4x. So what is 2x's plus 4x's? Good. Am I done?
No.
Okay, why not?
Positive 7 and negative 3.
Okay, let's get a different color. So I have a positive 7 and a negative 3. What does that give me? Positive 4. Okay, so what do I need to do to finish, keep writing this equation? So I want to keep writing this equation. So what do I have to say? So I bring down the 10. And? Good. Okay. So now we're on step 4. Combine the constants on opposite sides using inverse operations. What are my constants? And? So constants, so when we look over here, constants do not have, what is it? Yeah, because constants don't have variables, so 10 and positive 4. So we want to combine the constants using inverse operations, and the goal is to isolate the x, which means gets it by itself. So which one am I going to move, the 10 or the 4? Okay, how do I do that? Okay, how? Using inverse operations. What inverse operation am I using? Yeah, it is addition, so we're going to subtract from both sides. 4 minus 4 is 0. 6x comes down equals, what's 10 minus 4? Okay, last step is isolate the variable by using inverse operations. So what do we do? By 6. What does that leave me with, Izzy? So x equals 1. Is that correct? Well, it is, but what do we need to do to write it better? X equals 1. Just hand up if you got that one right. Okay. If you're missing these, do you see the problems that you're having? If you need help, please ask. Okay. So far, we've seen every step except step 2. See what you can come up with for this one. So we have 5, then the quantity of x minus 1 equals 20. Okay, Noah, you're walking me through this one.
Alright.
First step.
On the balance point,
Okay, where's that at?
the equal sign.
Go ahead.
Alright. And then go to your parentheses and you distribute 5 into, well, make x a 1x first.
Okay, so we're going to make that a 1x, and I hope you heard that because that's going to be important. We need to know, and that's awesome, Noah, that x really is a 1x because that's going to help us multiply. Go ahead.
Alright. And then multiply 5 and 1x.
Okay, so 5 multiplied by 1x gives me?
5x.
Good.
And then do 5 times negative 1.
5 multiplied by negative 1?
That'll be negative 5.
Ah, go ahead.
And then equal.
Okay.
And then add 5 to negative 5.
Okay, so you're exactly right, but do we need to combine like terms on the same side? Is there anything to combine with 20?
No.
How about on this side?
No.
No, because it's an x and a 5, we can't combine those. Okay, go ahead. Now what?
And then you add 5 to negative 5. And then you have to do the same to 20.
Okay, so because it says combine the constants, which are the numbers that don't have variables, using inverse operations, and the inverse of subtraction is addition. Go ahead.
So then you just get 5x and 25.
Okay.
And then you divide 5 into both.
Good. And that leaves me with?
Get x equals 5.
No, that's perfect, man. Very good. Questions here? Double thumbs up if you got that one right. Listen, you need to be asking questions if you're having trouble. Last one. Last one. The hardest of the day. Let's go with 3 minus 2. 3x plus 1.